كيفك أستاذ؟
كيفك كريست؟
كل شيء منيح.
الحمد لله. Good. You?
Good.
Good. في بنزين بعنجر ولا ما في بنزين؟
No.
نو بنزين؟
أنت عندك.
ما في كمان.
لا، هون كمان. هون عم بيبان عبوا بيبان 6 AM عم بيعبوا.
في عجقة كتير؟
يس كتير.
وينهم المؤخرين؟
I don't know. هلا we ride them.
This year you don't have the last bell?
I guess we have, but still, it's not sure if we will do it or not.
If you are going to do it, which day?
شو بدنا نعمل أستاذ؟
We're going to solve two questions logarithm.
Still,
Starting from yes.
التست على البان function or probability.
Probability.
Okay.
Send a message to Haikaz. Okay, let's start. Exercise number 4, part A. Let G be the function defined on 0 plus infinity by Gx equals x cubed minus x plus 1 minus 2 ln x. Show that G prime x can be written in this form. Show that G prime x can be written in that form. How to calculate G prime x? What is G prime x here? What is the derivative of x cubed?
Now 3x square minus 1.
Minus 1 minus, what is the derivative of ln x?
1 يبقى 2 into 1 over
Derivative
x.
x. We take the LCM, x, 3x cubed minus x minus 2. How to prove this? How to prove it is equal that? How to prove this one equal x minus 1 into 3x squared plus 3x plus 2. How to prove this one equal that one? If we expand this one, x times 3x squared, 3x cubed, plus 3x squared, 3x cubed, plus 3x squared, plus 2x, minus 3x squared, minus 3x, minus 2. 3x squared minus 3x squared cancel. We get 3x cubed. 2x minus 3x is minus x minus 2. So it is done. So G prime x can be written in the form. So G prime x equals x minus 1 into 3x squared plus 3x plus 2 over x. Any questions about the first part? Any questions about first part? Part 2.
أستاذ بس فيك تطلع اكتب هيدا.
Now study the variations of G. Study the variations of G. We study the sign of G prime x. To study the variations of G, we study the sign of G prime x. So this is G prime x. Hi G prime x. We solve it equal to 0. So G prime x equal to 0. It means the numerator x minus 1 into 3x squared plus 3x plus 2 equal to 0. X minus 1 equal to 0, we get x equal 1. 3x squared plus 3x plus 2 equal to 0. هذا إذا حلينا على الكالكوليتر أو لقينا دلتا بيطلع عنده no real roots. بيطلع دلتا negative, no real roots. So table of variations, we put g prime x, gx, 0, domain هو 0 plus infinity, and the value of x here 1, negative, positive, decreasing, increasing. To know the sign, we take a value greater than 1, we replace it in the derivative. Any value greater than 1 will give positive, negative. The minimum g of 1 بتعطي 3 minus 1 minus 2, g of 1 3 minus 1 minus 2 بتعطي minimum 0. 1 minus 1, we replace it in the derivative. 1 minus 1 plus 1 minus 2 than 1 تعطينا 1. The minimum is 1. Any questions, شباب?
No.
Did you write everything?
Yes.
Okay. Deduce the sign of gx. What will be the sign of gx according to the values of x? Part 3. Deduce the sign of gx. How to deduce the sign of gx? Who can tell what is the sign of gx here? From where we have to know the sign of gx?
Positive.
What did you say?
Positive. Positive.
Positive?
Minimum 1 يعني positive.
Minimum 1. So minimum of gx equal 1 greater than 0. So gx greater than 0 for every x belongs to 0 plus infinity. Gx greater than 0 for all x belongs to 0 plus infinity. Mary, any questions?
No.
No. Where are the ladies, ya Mary?
I don't know.
لسه بالمشفى والباقي ما عندهم نت.
Alisa Lash, what is the problem with Alisa?
عاملة عملية أنف.
Part B. Consider the function f defined on 0 plus infinity. Function f defined over 0 plus infinity by fx equal x plus 1 plus x plus ln x over x squared. X plus 1 plus x plus ln x over x squared. Designate by C its curve in an orthonormal system. The unit is 2 centimeters. Calculate limit as x tends to 0 with limit as x tends to plus infinity. How much is the limit as x tends to 0? إذا احتل محل x 0
minus infinity.
limit as x tends to 0 of fx بيعطي minus infinity. So limit as x tends to 0 plus of fx equal, we replace each x by 0, 0 plus 1 plus 0 plus ln 0 plus over 0 square. Ln 0 is minus infinity, over 0 plus is minus infinity. So limit as x tends to 0 plus of fx equals minus infinity. Limit al plus infinity, how much you get? We replace x by infinity. Limit as x tends to plus infinity. We replace x. We get infinity over infinity, indeterminate form. We apply Hospital's rule. We apply Hospital's rule to this part, to the fraction part. So we say limit as x tends to plus infinity del fx equals Hospital's rule equal limit as x tends to plus infinity of x plus 1. Hospital's rule, derivative over derivative. Derivative over derivative. Derivative del x1, derivative del n x is 1 over x over 2x. Equals. We replace each x by infinity. Infinity plus 1. 1 over infinity is 0 over infinity. This one becomes 0. So we get plus infinity. So infinity over infinity indeterminate, we apply Hospitals. بس not للx plus 1 للفراكشن. Derivative over derivative. Now part 2 show that the line D of equation y equal x plus 1 is an asymptote to C. How to prove this one is an asymptote? How to prove that this line is an asymptote, oblique asymptote? نجيب الليمت لل fx minus yd as x tends to plus infinity. Limit. Part 2, limit as x tends to plus infinity lil fx minus yd equal limit as x tends to plus infinity of x plus ln x over x squared. We get infinity over infinity indeterminate. Fx minus yd remains x plus ln x over x squared. Infinity over infinity, we use Hospitals. Limit as x tends to plus infinity. Derivative of the numerator, derivative del x1, derivative del ln x1 over x. Derivative del x squared is 2x. Has 0. So 1 over infinity is 0. Therefore, the line dy equal x plus 1 is an oblique asymptote to C. 3 part A. Consider or show that the function h defined by h of x equal x plus ln x is strictly increasing and that the function takes positive and negative values. How to prove it is increasing and it takes positive and negative values?
نعمل H prime X.
H prime x equal 1, derivative of x is 1. Derivative of x is 1 and derivative of ln x is 1 over x. It is always positive. Then the function is increasing. Limit على 0 بتصير 0 plus ln 0 minus infinity. Limit على plus infinity limit على plus infinity, we get infinity plus infinity is plus infinity. So the function is increasing from minus infinity to plus infinity, so it takes positive and negative values. The function h is increasing from minus infinity to plus infinity, so we start from a negative value to a positive value, so hx takes positive and negative values. Deduce that the straight line D, part B, deduce that the straight line D cuts C at a unique point of abscissa alpha, and alpha is between 0.56 and 0.57. How to find the intersection between D and C?
Y equal Y.
Y equal Y, or we solve fx minus yd equal to 0, or y equal y. So here, fx minus yd equal x plus ln x over x squared equal hx over x squared. So hx equals 0. We need to prove hx equals 0 has 1 root alpha. To prove this one, h is continuous and strictly increasing. h of 0.56 تطلع minus 0.01 negative. h of 0.57 تطلع 7.8 times 10 to the minus 3, which is positive. So alpha is between 0.56 and 0.57. So D cuts C at a point of abscissa alpha, 0.56, 0.57. So once again, to find the intersection, we solve fx equal yd أو fx minus yd. بيطلع لنا hx over x squared. h is continuous and strictly increasing. h of 0.56 negative, h of 0.57 positive. So alpha is between 0.56 and 0.57. Now part 4, study the relative positions of C and D. Study the relative positions of C and D. To study the relative positions of C and D, we know that fx minus yd equal to 0 at x equal alpha. We make a sign table. Fx minus yd equal hx. So هذا هون positive. Fx minus yd, before alpha it is negative, after alpha it is positive. C is below D, is a negative. Positive C is above D. Here D cuts C at alpha plus 1. So to study the position between a curve and a line, we make a sign table. We know it is 0 at alpha. Before alpha it is negative, after alpha it is positive. Negative, we say C is below D. Positive, C is above D. 0, D cuts C at alpha. To find the ordinate, it is easier to replace the value of alpha in the equation of the line. We get alpha plus 1.
Yes, I had the hx over x squared.
Where?
I had for fx equal yd minus yd equal hx.
hx over x squared, but x squared is positive. Doesn't affecting the sign. So we don't take, it takes the same sign of hx. Okay?
Okay.
5. Verify that f prime x equal gx over x cubed and draw the table of variations. Verify f prime x equal gx over x cubed and draw the table of variations of f. So f prime x, derivative of x is 1, derivative of 1 is 0. U prime, the derivative of, أنا كانت معنا الفانكشن x plus 1 over ln x. So f prime x equals derivative of x1 plus u prime v, u prime is 1 plus 1 over x minus v prime, which is 2x, into u. U prime v minus v prime u. 1 plus 1 over x into x squared minus 2x into x plus ln x over x squared, it will become over x power 4. Okay, it is written here. So minus 2x into x plus ln x over x power 4. Then f prime x equals we expand x squared plus x minus 2x squared minus 2x ln x over x cubed equals 1. I simplify x by x, the numerator and the denominator. X squared بتصير x, هاي بتصير 1. This one becomes minus 2x minus 2 ln x over x cubed. So we take the LCM x cubed minus x minus 2x is minus x plus 1 minus 2 ln x over x cubed equal gx over x cubed. So since f prime x equal gx over x cubed, x is positive, yani x cubed is positive. F prime part 6, this one, f prime x has the same sign as gx. But we have proved that gx is positive, so f prime x is positive. F prime x is positive. It is increasing. At 0 we get minus infinity. We have determined the limits. At plus infinity we get plus infinity. Okay, like take a break for 15 minutes. نرجع نكفي بعدين. Okay. We'll start at 2 and 5. Okay?
Okay.
Okay, أشوفكم بعد 15 minutes. يلا, باي باي.
باي باي.